and there is a disturbance, a change in concentration or pressure or temperature, how will the system respond? So the system is going to shift to the left to make more A. Last one would be temperature. Now, it matters if it's endo or exothermic. The last topic in equilibrium is applying LeChatelier's principle. So here's the principle. If you have a system at equilibrium, I abbreviate EQ for equilibrium, and there is a disturbance, a change in concentration or pressure or temperature, how will the system respond? Well, what we observe is that it will shift the equilibrium to counteract the effect. So let's look at some changes, and these are very logical, so you'll get this. So we have a system, A plus B is in equilibrium with C. What happens as we increase the concentration of A? Well, we have too much A down here, right? So what happens to Q? Q goes down, and what does it have to do? It has to get rid of that A. It's going to react some more A, and so we would say that would shift to the right. I would say shift right. And similarly, if we decrease A, let's say we remove some A from the system, what happens? Well, our denominator is too small, right? So we've got to make some more A. And so the system is going to shift to the left to make more A. So that's how you can determine a response to a change in concentration. Hey, systems will come to equilibrium. It may take a little while, but they will get there. The next one is pressure. Now, remember, pressure only matters when you're dealing with gases. So I have a reaction here, and every guy in the reaction is a gas. So they all come into play here. If we increase the pressure, what's going to happen? Well, look at the total number of moles of gas. I see 4 moles of gas on the reactant side and only 2 moles of gas on the product side. So if we increase the pressure, the reaction is going to be favored on the smaller number of moles side. So the reaction will shift toward the right. In other words, toward the fewer number of moles. And then if we decrease the pressure, what's going to happen? The opposite, it's going to shift to the left to the larger number of moles. Okay? The last one would be temperature. Now, it matters if it's endo or exothermic. So here's a little trick that I like to do. If I have a system that's endothermic, you notice I've got a positive delta H. I want to write that energy term as a reactant or product. And because it's endothermic, I know that it is a reactant. Now, increase the temperature. What happens? You're adding more heat to the system. So it's just like adding one of the reactants. What's going to happen? I've got too much heat. I've got to react it away. So it's going to shift to the right. It's going to go that way. Similarly, if we decrease the temperature, it's like removing some of one of my reactants. Well, the system's going to respond to make more of it. So it's going to shift back to the left. Okay, now let's look at an exothermic system. This time I have a negative delta H, so I'm going to put my energy term over here, right, as a product. Increasing the temperature increases the product, so we're going to shift it back to the left to get rid of some of that excess heat. If we decrease the temperature, I'm removing some of that heat. It's going to make up for it, right, by shifting back to the right. All right, I hope those little examples will help you. I think those LeChatelier's questions are really quick and easy, and I want you to get those right in your class. I hope this helps.